code here. Okay, looks like we got quite a few of you here. First of all, good morning. All right, just let me tell you about the agenda for the week. Today, we're going to lecture a little bit on the section on counting principles, but we will finish that next Monday.
Okay.
We will not meet on Wednesday because you guys will be taking the exam on Wednesday. Okay? The exam will be available for you on Mastering Lab for 2 days, Wednesday and Thursday. And don't forget to practice the review for exam 3 online before you take the test. Be sure you have a calculator and everything ready so that way you can do well on the test. Okay? And after this test, we only have left with the final. So after we finish this chapter on counting principles next week, we have left just a little bit of a section, basically a large section left. We'll do that and then we'll be done. Okay? And be always check your grades on Canvas. So you'll be taking the test Wednesday and Thursday. That means Friday morning I will transfer the grades from Mastering Lab to Canvas. Be sure the grades are there. Okay? So you should have only 2 grades on Canvas, exam 1 and exam 2. And by this Friday, you should have 3 grades, exam 1, exam 2, and exam 3. The homework grade will be average when we're done with all the homework. So I'll drop 1 homework grade and I'll average the rest and I will put that on Canvas. So on Canvas, I'll only put the average of all your homework, not grade by grade. Okay? All right. Does anybody have any question before I start?
Okay, take it out. Okay, take it out. That's your life. Okay.
Any questions? Everybody good?
Yes, question. When class finishes in May, do you have access for the my lab to do some exercises later on, or it will close the program?
Oh, no, it shuts down. That's it.
Blood pressure.
Yeah, you don't have access after that. I have it set up, I think, till mid-May or May 20. I don't remember when I have it set up because I have so many classes. But whatever it says, you can use it. You can check when you can use the due date. But I think I have it set up like May 20 or something. Yeah, because the course will be over. That's it.
So,
Okay?
do you have the right to extend a little bit, because some principles, some chapters I didn't get still, and I need time to do all these over.
Oh, you mean, look, I'm going to be average the grades. Why do it over? Because, like May 12.
No. I not for grade, just to understand the principles.
Why don't you text me later on and I'll check it for you. Text me later on and I will see if I can extend it or not. Okay? Yeah. Just
even though it's just to practice, it doesn't has to be to grade it.
I understand. Text me later on and remind me and I'll check into it for you. Okay?
Thank you.
Yeah. Those special questions, we don't want to really waste the time on the lecture talking about them. You can always text me these individual questions. I can answer those for you individually. Okay? But I'm talking about the course. Everybody okay? All right. Let's get started, class. I'm recording this lecture now. So Remember, we don't meet on Wednesday, so you have 2 days to finish the exam, Wednesday and Thursday. Okay? And those of you who are taking 2 courses, 0324 and 1324, you have to take 2 exams. Okay? All right, let's get started. So, what is this chapter about? This chapter is about counting principle. Okay? It has 3 sections. So, we'll try to finish 1 sections today. So, what does it really do here? Well, basically, this section tells you this. Let's say you have 9 players that play baseball. And you want to say how many different batting order can you have them in? For example, this guy can bat first, the second, third, fourth, or this guy can bat first. So can you tell me the number of different orders I can have those players? That's called the counting principles. Let's say you have 5 different meats. You have a party in your house. That you're offering 5 different meats: chicken, bacon, burgers, whatever, and you have 6 different chips and 9 different drinks. And the question is, how many different lunches can you make out of these particular ones that I gave you? That will answer the question for you today. Or you might have a question, you know what? Let's say I work for the state of Texas. I want to see how many different license plates I can make out of 6 numbers, and I can repeat the numbers. Or how many license plates I can make out of if I use 3 letters and 3 numbers. That will be answering for you today. Okay? All right. First of all, let's talk about the easy counting principles. Let's say I have 3 pants and 2 shirts. Question is, how many different outfits can I make out of these? So let's say the pants are black, blue, and brown. And the shirts are yellow and white. Because I have 2 shirts and 3 pants. These are the shirt, these are the pants, these are the shirts. Every time I change one thing, I'll have a different outfit. I can wear the black pants with the yellow shirt. That's one outfit. I can wear the black pants with the white shirt. That's another. Or I can wear the blue pants with the yellow shirt. That's another outfit. I can wear the blue shirt with the white. The blue pants with the white shirt. That's another outfit. Or I can wear the brown pants, yellow shirt. That's an outfit. Or I can wear the brown pants and the white shirt. Another outfit. So I'll have 1, 2, 3. So I can have 6 outfits I can make out of 3 pants and 2 shirts. That's the way to go about it. But what does Mastering Lab teach you? They teach you something that's stupid. Basically, they don't tell you this is how it goes. They just tell you just multiply 3 times 2 and you get 6. But I want you to understand how they get the 6 by counting it. Okay, does that make sense, class? So I can wear 6 different outfits if I have 3 different pants and 2 different shirts, and that will be the answer. Does it make sense?
Yes.
Okay, go ahead and copy it, please. We're going to focus on this first, okay? So I like to go in details to teach you why they come up with the number 6. I'm not the professor here that's going to tell you multiply 3 times 2. I want to tell you why, okay? So everything I'm going to teach you in this class, you need to know why, because that's what math is all about, not just multiply these numbers, okay? All right, go ahead and copy it here, and I'll show you another example. Are we doing good so far? Okay, let me know when you're done copying so I can show you another example.
His pants are all blue or blue, brown, and what kind of color they also? Blue?
Black, blue, and brown.
Black.
Some examples. You can pick. I'll just show you how do I get 6. I don't want to just show you just multiply 3 times 2 to show you how many different outfits. I want to show you an example. You can bring different colors. Excuse me. So it could be, it doesn't matter. You know, the problem is not going to tell you the colors. I'm just picking up any colors just to show you that if I take one of these with 2 shirts, that makes it 2 outfits. One of these with 2 different shirts, another 2 outfits. This pants with another 2 shirts, there's another 2 outfits that makes it 6. So I just gave you these black, blue, and brown just to make you understand where they get the number 6 from. You can make the pants to be not necessarily black, blue, or brown. You can make them white, purple, and green if you want to. It really doesn't matter. But I like to give you the specific ones to make you understand how we get the number 6. Okay? Do you understand what I just said?
Yes.
Okay. All right. Can I erase the board now? Are you all done? Okay. So let's say I have 5 different meats. And 4 different chips. And 3 different drinks. So how many different lunches can I have? Can I make? How's that sound? Okay. So 5 different meats. Maybe you have turkey, bacon, chicken, burger, salami, whatever meat you can think of. 4 different chips. Could you have Lay's chips, barbecue chips, whatever it is. 3 different things could be Coke, Sprite, and Dr. Pepper, maybe. So different lunches means every time I change one of these, I'll have a different lunch. Let's say the turkey. I can do the turkey sandwich, the Lay's chips, and a Coke. That's one meal. Or the turkey sandwich, the Lay's chips, and Dr. Pepper. That's another meal. Or the turkey sandwich, Lay's chips, and Sprite. That's another meal. So every time one of these 3, I'll have a different what? Lunch. All I have to do is change one of them. So in order for me to count them, I can just put the different meat and take the first meat, put it with what? The same chip, but different drinks. Then the same meat, then and so forth. But instead of me writing all of them, now I know what I do. To find how many different lunches, I just multiply 5 times 4 times 3. And the answer is I can make 60 different lunches out of 5 meat, 4 chips, and 3. I don't have to go and break them down for you. So whenever you want to find the number of different things here is, you just multiply these 3 numbers together. Okay, does that make sense, class? So I can make 60 different lunches out of 5 different meat, 4 different chips, and different drinks. Okay? You can go ahead and copy it. Okay, how we doing so far, class? Okay, can I erase the board now?
Yes.
Okay. All right, now, today, another thing you need to know about is, what are the types of counting? There are two types of counting principles. One is where what? Repetition is allowed. What does that mean? If I use the number 2, I can repeat the 2. A repetition is not allowed means if I see the number 2, I can only use it one time. Okay, here's an example. I always like to give this example to understand how math works, class. So here's an example. How license plates can be made out of 6 digits. And I'm going to tell you what, repetition is allowed. Okay, so look how math works, class. Here's 6 digits. 1, 2, 3, 4, 5, 6. How many different license plates I can make out of 6 digits with orders allowed? So I can have 0, 0, 0, 0, 0, 0 as one license plate because I can repeat the digits. Or I can have 0, 0, 0, 0, 0, 1. Or I can have what? You don't have to write these down. All the way to zeros to 9. So 1, 2, 3, that's 10 of them right here. Or I can have what? 0, 0, 0, 0, 1, 0. Or 0, 0, 0, 0, 2, 0, and so forth. So if I'm going to have here 3, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? So basically, I have 6 digits. If you think about it, here's the 6 digit. 1, 2, 3, 4, 5, 6. This one is going to be 10 times. This one's going to be 10 times from 0 to 9, 0 to 9, 0 to 9, 0 to 9, 0 to 9. So if I want to count how many different license plates I can make out of 6 digits, since I can go from 0 to 9 here, 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 0 to 9 here. So I'll have what? 10, 6 times 2, 3, 4, 5, 6. And the answer is 1 million. So I can make 1 million license plate number if I can make the license plate only made of numbers, digits, nothing else, no letters yet. Because look what happened. I gave you an example. If I start with the zeros, I keep these zeros, but I change it from 0 to 9. That's 10 of them. And I have to do the same thing here, 10, 10, 10, 10, 10. So 10 times itself, 6 times, it give me 1 million. So out of 6 6 numbers, I can make 1 million different license plate numbers. Does that make sense, class? Okay, why? Because repetition is allowed, means I can use each digit as many times as I want to. I can repeat it. Okay? All right. So you don't really need to copy this class. All you need to copy is what? I have 6 digits, so that I multiply 10 by itself 6 times. So what if I want to use 3 letters and 3 digits? And I can, these are letters, and these are what? Digits. Then how many license plates can I make? There are, remember, repetition is allowed. How many letters are in the alphabet? It'll be 26, 26, 26, 10, 10, 10. So guess what? That would be the answer to, if I use letters, I can make more license plates. Why? Because there are 26 letters in the alphabet as opposed to 10 digits out of the numbers. So if I go to my calculator here and I multiply, let's go to my calculator here. If I multiply 26 times 26 times 26 times 10 times 10 times 10, guess what? I will get 17,576,000 different license plates. That's why your license plates class has letters in it. Because when you put letters, they can give more license plates, right? So every time you put, if you use only numbers for license plates, they, guess what? There's only a handful of, 1 million is not enough. You have about 30, 40 million cars driving around here. That's why they use letters. That way you what? You'll have more license plates. And of course, if they use all letters, you're gonna have 26 times 26 times 26 times 26 times 6 times 6. And if they use more than 6 slots, you're gonna get more. Okay? As you're copying it, if you have any question, let me know, please. So how we're doing so far, class? So how we're doing, class? Everybody doing good?
Yes.
Now we're gonna go with the ones where you cannot repeat the numbers or the letters, okay? We're gonna teach you, have a calculator ready. I gotta teach you how to use a calculator first. All right, can I erase the board now?
Yes.
Okay. Now, get your calculator ready. We need to learn about factorials. Okay. You cannot learn. Now we're going to work where repetition is not allowed. Okay. First of all, let's learn something here. You cannot learn it unless you know how to use a calculator to find certain things.
Can you
And
slide
with
your
an
camera up?
exclamation mark. I'm sorry?
There you go. Thank you.
The way you read this is n factorial. Please don't call it X mark. This one is needed for counting principles when order is, when repetition is not allowed. What do we mean by n factorial? N times n minus 1 times n minus 2 all the way to 1. For example, how much is 5 factorial? Don't call it exclamation mark. It's 5 times 4 times 3 times 2 times 1. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. So 5 factorial is 120. So if I tell you what is 7 factorial, it'd be 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, you could go do that by hand, or if you guys have your cell phone with you, I can show you how to find 7 factorial on your cell phone, or on your if you have a calculator with you. So all I gotta do here is, watch what I'm gonna do here, is I go to calculator, I press 7, and you can see X factorial on your calculator like this. Do you see that? If you hit 7, then that key, you should get 5,040. Which is the same thing as multiplying 7 times 6 times 5 times 4 times 3 times 2 times 1. Can everybody see that key in there? Yes or no?
Yes, I see it on my calculator.
Okay, did you get 5,040?
Yes, I did.
Okay, so let's say I want to do 4 factorial. It'd be 4 times 3 times 2 times 1. You can use a calculator, you can, this is easy. 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is 24. So 4 factorial is 24. But you need to keep one thing in mind. 0 factorial is not 0. Whenever you see 0 factorial, it's always 1, not 0. Okay? So, here's an example. Let's make it a little harder. How much is 8 factorial divided by 6 factorial? So I can do it like this. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 6 factorial is what? 6 times 5 times 4 times 3 times 2 times 1. 6 all the way to 1 is going to cancel all the way 6 all the way to 1. So what am I left with? 8 times 7, which is 56. Or I can work smarter. 8 factorial, I can write it 8 times 7. Instead of going from 6 to 1, I leave it as 6 factorial. Why? Because 6 factorial and 6 factorial cancels out, and am I left with 8 times 7, which is 56. Okay, do you all understand? Or I can go to my calculator, and I'm going to do 8 factorial, 8 factorial divided by what? 6 factorial equals, and I get 56. Okay? All right, go ahead and copy the board, class, and as you're copying it, just let me know. And we'll go from there. So now you have multiple ways to find the factorials. Please, again, don't call it exclamation mark. Please, class, you guys are educated now. You don't need to use words that don't make. So now that you understand what the factorial is, now next thing we just need now to focus on one more thing today, and we'll be done. And that's how do we find the number of arrangement when repetition is not allowed. So if you know how to find factorials, you can understand the next topic here. Okay? How we're doing so far? Is everybody understanding what I have on the board?
Yes.
Okay, good. Okay, can I erase the board, class, now?
Yes.
Okay. So now we're going to talk about things where what? Repetition is not allowed. You cannot repeat the same number or same letter.
Professor, we can't see what you're writing.
How's that now?
It's better.
Okay.
Thanks.
Good. All right. Repetition is not allowed. What else? Order is important. So what I'm going to show you now is how to do things by hand, and I'll teach you the formulas like the book. The book right away gives you the formulas without explaining to you why. Let's say I have 3 letters, A, B, C. Now remember, repetition not allowed means I cannot use A twice or C twice, only one time. So the question is, how many arrangements of 2 letters are there? out of these three letters. So let's start with A. Remember, order is important. What does that mean? AB arrangement is different than BA. Think you have a lock and you want to open it. If you put the numbers mixed up, it's not going to open it for order. So let's start with A. I can have two letters, AB. That's one arrangement of two letters. Or what? AC. See? Or I can have what? B. No, I'm done with the A. Now I'll do B. BA. Or BC. Or what? Now do the C. CA. Or CB. So I'm getting two letters out of these in order. So I have 1, 2, 3, 4, 5, 6. So I can arrangements of two letters out of the ABC without repeating the letters A, B, or C. So the answer is there are 6 arrangements. You don't have to tell me the breakdown. I'm showing you the breakdown so you understand how the computer or the calculator will give you 6. So I can make 6 2 letters with different order out of the 3 letters A, B, and C. Okay? Now, how does your book teach you how to do this? The book teaches you this. Anytime repetition is not allowed or order is important, we call that permutation. So what's the definition of permutation? Repetition is not allowed and order is important. What do we mean by order is important? Means AB, I counted different than BA, although they're the same 2 letters, but the order is important. Now, how does permutation work in counting principle? So remember, you use permutation where? When you cannot repeat and the order is important. The formula for permutation is PNR. N is called the total number of elements and R is how many are taken at a time. And the formula is n factorial over n minus r factorial. And I will, when everybody copies this, I will show you what I mean by the formula. But first of all, go ahead and copy it first, okay? Just copy the board and I'll explain that to you, what this formula means and how to apply it in this problem. But I don't want to go too fast on this one here. Go ahead and copy the board, class. Okay, so let's look at this problem, class. Is order important? Yes. A, B, 0, and B, A. Is allowed? Correct. I can only use each letter once. So if I don't want to list those numbers and count them, that takes forever. Okay, your book doesn't list them for you, gives you the answer. So I use P. How many total letters do I have? 3. How many am I arranging? 2. So how do I work this formula? It'll be 3 factorial divided by, look at the formula here, you subtract. 3 minus 2 is 1 factorial. And 3 factorial is 3 times 2 times 1. And 1 factorial is 1. So what's the answer? 6. It's the same answer I got by using formula. So your book goes straight as you find different arrangement from 3 letters. I want to arrange 2. They go straight like here. But I'm teaching how they got the 6. So you don't really need to copy this if you don't want to. But I really want you to understand how counting the arrangements work. So why do I use permutation P? Because I cannot be and important. What does order important means? A is different than BA. AC is different than CA. Means that I have to count both as differently. Okay? All right. Now you can finish, you can copy this here. So this is another way of finding this answer, much faster way. Okay? Now that you know what it is, now we're going to work on more word problems using the permutation. Okay? All right. Go ahead and copy it. Okay? Can I erase the board now?
Yes.
Okay. Now we're going to work on permutation for today. And then next week we'll work on combination where order is not important. Okay? All right. Let's start working some word problem. Here's an example. Let's say I have 6 seats and 4 people. How many arrangements are there? Okay. First of all, order is important. Imagine you have 6 seats in your classroom, and I have 4 people. Don't copy this class. Here's 6 seats. So what do you mean by how many different arrangements are there? Let's say I have John, Mary, Alan, and Solomon. And these are the 6 seats. That's one arrangement. I can have what? Solomon here, A here, M here, J here. That's another. Or I can have what? 1 here, 1 here. So every time I move 1 student, I have a brand new arrangement. And of course, order is important. Why? Every time, if I tell you where is Mary seated, you can say it's second from the left or third from the left. So that means order is important. And of course, you cannot repeat it. You cannot clone people, right? So in this case, since repetition is not allowed, and also I use P. How many total seats I have? 6. How many people am I arranging? 4. So the answer is going to be 6 factorial over 6 minus 4, which is what? 2 factorial. And 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 2 times 1 cancels 2 times 1. Now I go to the calculator and multiply the numbers that are left. 6 times 5 is 30. 30 times 12. It'll give me 360. So there are 360 different ways I can put 4 people in 6 seats. I just showed you an example of it, and that would be the answer. So how we're doing, class? I just showed you examples what I'm talking about in the problem here, okay? So we're doing good?
I just got one question. Right there, where
Uh-huh.
you got 2, where you get 2 from?
You subtract 6 minus 4.
Okay, cool. All right.
Yeah, that's what formula tells you. Any other question? Don't just copy, class. If you don't say a word, means I take it that you understood it, okay? All right, so when you copy it, don't just say that I don't get it. I'll give you time to ask questions here. I'm going to give you more examples in a minute, okay?
A question. In previous example, we didn't subtract. There was example 3p2. Why
Yes,
we
I did
didn't?
subtract. It'll be 3 factorial over how much is 3 minus 2? 1 factorial. So 3 factorial over 1 factorial is 3 times 2 times 1 over 1 factorial. 1 factorial is 1. Remember? P32 we subtracted. It'll be 3 factorial divided by what? How much 3 minus 2? 1 factorial. 1 factorial is 1. That's why you get
See.
6. Do you see it
I
now?
see. Yeah.
All right. Good question. I'm gonna revisit this again with you next Monday, okay? Because this stuff is important. So I will repeat some of the stuff for next week also. Because we only have combination. So I want to teach you how you look at the problem. How do you decide to use this or this or that? That's going to be a big challenge, but I'm going to teach you that next week, okay? But for now, just learn. I'm telling you now.
Is this factorial is division factorial?
Division? What do you mean by division? This line is
Because
division line. That's division right here.
yes, and they are also multiplication factorial, and then plus and minus factorial also exist.
No, never.
Okay, only division factorial exists, right?
That's correct. you're talking about formulas, you don't have times, okay? But sometimes they might ask you how much is 5 factorial plus 2 factorial. That's like, doesn't have to do with the number of or counting principles. Counting principles doesn't have adding or multiplying factorials. It just has to do with the, you know. So don't get these two confused. All right, let's give you another example. Let's say I have 5 slots in a bookshelf. 5 slots. And I have 3 books. How many different arrangements can I put the 3 books? All right. So I have what? 5 slots, and I have 3 different books. How many different ways I can put the 3 books? For example, let's say I have a math, physics, and chemistry book. I can put them in these slots, or I can put what? Math, chemistry, and physics books. That's another slot. Or what? Math, chemistry, and maybe physics over here. Every time I move them, I get what? A new order. Can you give me how many different ways I can put these 3 books in these 5 slots? First of all, you cannot repeat the math book. So order, repetition is not allowed, and order is important. So what I do in this case? It'll be P, total number of elements is 5. How many arranging is 3? So that's going to be 5 factorial, 5 minus 3, which is 2 factorial. But 5 factorial is 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 2 times 1 cancels 2 times 1. And then 5 times 4 is 20 times 3 is. So there are 60 different arrangements I can put these 3 books in the 5 slots. Okay, does everybody understand what I did here? Are we good so far? How we doing, class?
To find out the numbers and multiply to each other, first of all, we have to arrange the letters, right? Left and right, and then count them, how many of them, and then we can multiply for numbers, right?
You don't have to arrange it yourself. The reason I put these for you, arrange them just to make you understand the question. Okay? So all you have to do is how many slots I have, the large numbers on the left, how many am I arranging? 3, 5, 3. And you do the work. The reason I'm showing you this, because I don't want you to learn math by, just do this number over this number. No. I want you to understand what does the question want. So let's say you don't know math, right? Then you're going to be here all day long to count. Says, I can put it here, here, here. 1. Or I can put here, here, here. 2. Or I can put it here, here, here. 3. So if you keep putting them different times and counting them, you're going to be here forever. But this formula tells you, what? For sure, there are 60 different ways I can put these 3 books in. Okay? The reason I break it down like this is to make you understand what the question wants. But you don't have to do this work. Do you understand me now?
Yes.
Okay. Because you don't do math by pattern. You do math by understanding what the question wants.
Right, but in previous example, you count like A, B, C, B, A, A, C.
Yeah, it's easy to count those 3 letters. You count 2 here. I'm not going to spend all day, all night teaching you how to count. Imagine I want to count how many I can put 3 books in 5 shelves. And here. Then what? I'll put C here, P here. That's another. Or C here or here. So if I want to put it down, I'm going to need about I'm going to need about 20 boards to count to get 60 different ones here. Okay. I gave you 3 letters, how to find combination of 2 letters because it's easy to count 2 out of 3, you know. But when you have a large ones like this, I'm not going to count it for you, but at least you understand what the question was. Do you understand now?
Yes.
Okay. Okay. Let's give you another example. Let's say I have now 7 CDs. You have a party in your house. And you get 7 CDs to play. How many arrangements are there? It means how many different orders, let's put it this way, how many different orders can you play them? Okay, for example, here's 7 CDs stacked up. 1, 2, 3, 4, 5, 6, 7. Okay, I don't know what kind of your flavor of music is. I can play this one first, this is second, that's third, that's fourth, that's fifth, that's sixth, that's seventh. That's one order, right? Or I can pick what? The second one I can make it what? First. And then what? Second, third, fourth, fifth, sixth. Or what? I can break the CD number 7 first. The question is, can you count how many different orders I can put them in for the people to listen to the music? So the answer is going to be P. I have 7, but I'm arranging all 7 of them. Okay? So the answer is going to be what? 7 factorial over what? How much is 7 minus 7? 0 factorial, which is 1. So the denominator is 1. So don't do 7 times 6 all the way to 1. Let the calculator multiply it for you. So if I go to my calculator, 7 factorial, I get 5,040. So there are 5,040 different ways I can play these 7 CDs. I can make this is first, second, or what? I can play it first and so forth. Now, what if I tell you I have 7 CDs? Let's call this part A and this is part B. How many arrangements of 3 CDs I can play? Then I use what? P 7 3, which will be what? 7 factorial over what? 7 minus 3, which is 4 factorial. So if I go to the calculator, I don't really need to go ahead and do all of this math. I'll do 7 factorial divided by 4 factorials, and I hit the equal sign. And the answer is 210 different arrangements I can play 3 out of these 7 CDs. Means 3 at a time. Okay? You can copy it and let me know if you have any questions. All right, with this one class, you can copy it, and that will be a perfect place to stop here. Right? Let me know if you have any question as you copy it. And don't forget that we won't meet on Wednesday, right? Because you guys will be taking the exam. Okay? Once you copy it and you have no more questions, I'll see you guys next Monday.